Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Welcome to this week's episode of the Distributed Data Show. I'm Jeff Carpenter. With me is Jonathan Lacefield.
Hey Jeff, how are you?
Welcome back to the show. We've had you on before. You didn't bring Denise with you this time.
No.
Or she didn't bring you, or...
That's more accurate.
Oh yeah, Dr. Denise Gosnell, favorite guest of ours, but you are both very fond of graph databases, and we want to talk with you about what trends we're seeing with graph databases.
Yeah.
But before we do that, I like to set context, so we have a little bit of the history of graph databases in general, the DataStax take on that involvement with graph databases. We have our own product, DSE Graph. Can you trace a little bit of that history for me?
Yeah, and as part of that, let me just give some context about my role with graph databases. So Denise is very much out in the field. She's an expert, PhD in graph. So I come from a different background. I was a solution architect with DataStax for a long time, kind of generalist, information architect, enterprise architect. And 2016, I took over the product management role for Graph.
Right,
so
okay.
I have product management responsibilities for Graph, which is great. I came out of what we call the field or services from working directly with customers, and now trying to solve their problems, but from our product perspective, from within our engineering org. And what's really sweet is that I get to either see stats or more ideally work with a lot of customers in a lot of ways. And what's really nice is that I listen. So it's not my job to go in and actually fix a problem, it's to listen to
what is the problem.
Right.
It might not be what you first thought.
Right, and then generalize that back. But yeah, so with that context, a history of graph databases at DataStax. So I think late 2014, early 2015, somewhere around there, we purchased a company named Aurelius.
Yes.
And so Aurelius, they did two fundamental things in the graph space, and I'm going to use that term very explicitly, graph space, not just graph database space.
Sure.
So, it was a small company of experts in computer science, and they were solving graph problems. And two of their major inventions were, first, Apache TinkerPop, which is a graph processing framework. A lot of tools for graph processing, and one of the main ones is the language or API they use to express graph queries, which is called Gremlin.
Gremlin, okay.
So Aurelius created that, and then they also had, and that was done by Dr. Marco Rodriguez. And then his partner in Aurelius, Dr. Matthias, and I'm going to butcher his last name, I'll give it a shot, Broecheler, created really a prototype and a pioneering distributed graph database. So graph databases have a kind of a mixed history. If you look in the supercomputing space, they kind of have been around for a little while, but really they've been around, I would say, about 10 years or so. So it's a relatively young database category. And what Matthias did was look at trends in big data and NoSQL and apply distributed processing and combine that with graph problems. And he created a distributed graph database, open source, named Titan.
Gotcha. Okay, so there's a distinction that you made that I want to kind of pick up on a little bit there between graph processing and graph database.
Yeah.
Is that important to us to understand?
It is, right. So graph processing, really all the graph pieces have their roots inside of pure mathematics, right? This is where Denise shines. This is her PhD area of focus. So I can have data structures that are columns and rows or whatnot, and apply graph techniques. A classic example here is Google PageRank.
Yeah.
PageRank is a graph algorithm. It walks across a network and really cares about what we call connectivity in graph. How many views does this page have, and how does that influence the popularity of this page, and so forth and so forth. And it goes through a network of things. That's graph processing based in mathematics. And that is different than a graph database. A graph database is optimized to store data in a data format that makes processing faster or solves a part of that processing problem.
Right. Okay. Good. So the idea of their and what TinkerPop, I guess, and Gremlin are providing us are kind of the tools for expressing those analysis of the relationships that we need to perform for our applications, and then we need the storage underneath that kind of helps optimize that access and traversing those relationships between nodes.
Yeah, a good way to think of Gremlin is we needed a way to natively express graph processing against data structures. We needed a way to programmatically do that without having to reinvent that every time. Kind of like what SQL did for relational databases or querying rows and columns and tables. We needed something like that for graph processing. And that's what Gremlin gives us, is a nice API to do just that.
Okay, good. So I took us down a digression a little bit, but I hopefully kind of helps educate us a little bit more. I'm definitely learning things all the time here about the key elements here in the graph world. So take us there was an acquisition of Aurelius.
Sure.
And then we did something with that inside DataStax Enterprise.
That's correct. Yeah. No, that sums it up. We did something.
We did. Boom, product.
Boom, right. No, what happened is, so the Titan code base, Matthias has a great story he tells, but the Titan code base actually came a lot of it out of his PhD work, and it sat dormant for a while, and then he did a startup, came back, and kind of rebooted. So what Aurelius did, they looked at DataStax, and they were excited to come to DataStax because we had this distributed data platform, and it already solved a lot of the challenges they were facing with their open source Titan database. And really what it comes down to is Titan was a graph database processing engine. Think of it in real simple terms as like a query optimizing engine.
Yeah.
Sitting on top of a pluggable storage engine.
Okay.
Typically Cassandra, could be HBase, could be Berkeley DB.
Yeah.
And then they had a separate pluggable indexing engine. And the reason for that, and something that's become apparent to me, is most graph problems are search problems, and we'll come back and revisit that thought later.
Yes, please.
But they had all these three different, broken apart pieces, and they saw DataStax with our nice integration already there, and they're like, holy cow, we have an opportunity to work with some top engineers, and then we have an opportunity to greenfield our ideas and really take a second full pass at it. And so they were excited to come here, and that's what they did. They took the lessons they learned from building Titan, all their customer experiences, and Gremlin is a standard API, and it's you become certified on TinkerPop and Gremlin from a database vendor perspective.
Right.
They applied all that, and they built DSE Graph from the ground up, essentially, as a second pass at solving these graph database problems.
Right. Okay, so it sounds like they actually had a workable product that was useful to people, but I'm guessing, reading between the lines, problems of scale. Is this right? Like what what drove that need for that integration with Cassandra and more search indexing, flexibility, et cetera?
It was scale, but there were also some fundamental challenges with Titan with essentially consistency and synchronizing data, because they had these pluggable engines. Your indexes could become very out of sync with your data.
Okay.
And that was a real, when it comes down to a fundamental problem, design of having that pluggable architecture. And so they had tools they would run, they would take your graph offline and whatnot.
Okay, interesting. Yeah, so the ability to kind of like read your writes and have your indexes be up to date, in sync.
Right, and accurate.
Yes.
Yes, yeah. And then from there, it is scale and it's processing. And by working within the construct of DataStax, we can solve bigger problems. So when you look at how we're attacking graph analytics, so remember we first spoke about graph processing being a thing and graph databases being a thing. Graph processing really happens, a lot of it, in an analytical construct. I need to do something with my full graph or big subgraph, right?
Yeah, so what is it that makes it an analytic problem? Is it that scope of the fact that you're scanning across your entire data set, or how do I know that it's an analytic problem?
Sure, two real things there. There are, again, PageRank or finding shortest path. There are analytical algorithms that I'll want to perform on a graph. And to do that would be analogous to finding, let's say, the most popular people within my network of customers, influencers, if you will. That's a very classic connectivity type of algorithm that is very math heavy, very computational heavy, very analytics heavy, if you will. Okay, so that kind of falls, or I need to do a traversal across my entire graph. And then one of those things, so it's either the size of the data, if I need to scan, like do a full scan, or I'm going to do something very analytical in nature, would make it a graph analytics problem.
Okay.
And what was cool, though, just to finish that thought out there, is because we are, DSE has this deep integration with Spark, what traditionally would happen, you would pull out, and this is with most graph database vendors, and it's still true today with a lot of other graph database vendors. Very traditional data architecture thing. I'd have this graph database that was set up to do operational traversals. Okay. And then I'm going to extract that full graph, put it in something like a Hadoop, or some kind of flat file format, and then run graph analytics on it with like Spark or.
And then I need a different processing engine, to run those analytics jobs.
Yeah. Okay. So what's sweet? So they're coming here and they're like, holy cow, you have Spark already integrated. The data movement's already handled. I have a way just to very simply isolate workload, and my data's already there. It's replicated there. I can run, graph analytics without fully extracting all my data and going through that full problem. And if you really look at what Marco was shooting for with Gremlin, was the ability to have kind of blur the lines between transactional and analytical processing. So I have a traversal.
So we can do that now.
Right, right. That's exactly right. And maybe this traversal, because of the data size it's going to, should be an analytics thing, but why are we providing that complication to our users, right? It's a graph processing problem. Let's let the engine figure out the implementation details for how to execute that process.
Okay. Excellent. So we support that now, is that you don't necessarily have to be that conscious of whether this is
we are taking steps to get there. So right now we have the ability for a user to write one piece of Gremlin and to say, I'm going to run it transactional or I'm going to run it analytics. Right, and it's literally just how I execute it. So if you're using our Studio product, which I know you're a fan of, I am as well.
Big fan.
Literally just say, I'm going to run this as transactional or analytical. But yeah, where we're heading, if you look at our roadmap and how we're releasing software, it's very much to take advantage of the unified platform of DataStax. So our users wouldn't have to necessarily, for simple type queries, there are times where they would want to be explicit with analytics. Good. But where they're heading, is, hey, I don't have to think of that complexity. Is this graph transactional processing or graph analytics processing? It's a graph process. I have a graph database. It'll handle all the execution for me. Good. Okay. So we've started to talk a little bit about some of those future directions, but is there anything else that you want to summarize? I know that we've had 3 releases of DSE Graph now, counting this latest release with DSE 6. Right. So is there any brief history that you want to trace about how that's matured before we kind of look forward into the future? Yeah, so probably the first thing to talk about is the first release of DSE Graph was actually with DataStax 5.0, DSE 5.0. Yep. So, we don't really count graphs separately, so it's just DSE Graph 5.
It's part of that's right. It's been in 3 DataStax releases.
Right. And we've had really good adoption, which is, for my role, it's wonderful to see. So we're getting a lot of great feedback, and it's helping to shape our roadmap. Some of the original assumptions, going out there, we're like, well, maybe those didn't turn out right, and that's okay because we have the ability to react to that. So over the past almost year and a half, almost 2 years now that Graph has been a product, really looking at features to help it scale and driving those down into our database layer, which would be the DataStax version of Apache Cassandra. So this is where things like in the latest release 6.0, where thread per core really helps Graph from a processing perspective.
Yeah, you're reaping the benefits of those 2x performance improvements.
Absolutely. All the advantages of all the effort which we put into our Spark integration, things like JDBC and having always on SQL. What's really cool about our Spark integration, what we're trying to build is really a unified multi-model. So I store data once, I can access it through CQL, through Gremlin, through Spark SQL, what have you. And we're almost there, right? Today you have a graph model and you're going to access it with either Gremlin or analytics. But here's what's really cool about what we've done with 6.0 and our analytics story. With Spark SQL, Or if I don't want to use Spark SQL, just use something more native to Spark like Scala or Java, what have you. I can combine data that's stored in my graph, data that's stored in CQL, data I have in a flat file that's stored on DSE and process all that together. And this is really handy for a big use case of ours, which is like building customer 360s.
Right.
Because that inherent capability is required to execute entity resolution problems. And I know Denise has
we talked about it.
Okay.
Yeah, this is, for me, this is kind of really helping to flesh out that vision of what a true multi-model capability really is. It's not just about the fact that I can actually access data using multiple different kind of data models or ways of looking at data, but also that we have this graph processing engine that it's able to do that on our behalf, that I don't have to be extracting data from one kind of data model and inserting it into the graph so that I can then do graph processing on it. It's more really kind of like an integrated product under the hood.
It is, and what the biggest learning for me when I started in June 2016, right when we released DSE 5.0. I started in this role. I've been DataStax almost 5 years now, but graph processing doesn't necessarily mean graph database. And we said that in the beginning.
Yeah.
And what our customers have learned and what we're helping to enable is that multi-model story. I have a graph problem, but I need to solve that with the right tools for each, breaking down a problem like we
and
did
existing data sources.
Right. Right. I don't necessarily need to do everything in Gremlin. Okay. Cool. Right. There are things, if I just want to know like simple heuristics of what's in my graph, maybe SQL's the right way to go because I have a BI tool. If I need to do, so match intensive processing, maybe, analytics with push down into DSE search is the right way to go, is the right tool. I don't necessarily need to do that in Gremlin. The point is a lot, what I've learned working with customers is that the original thought from a customer is, I have a graph problem, I need a graph database. And what we actually do is we come in and we say, look, this is a graph problem. Or no, it's not, but a lot of times it is, yes.
A lot of times it is.
Right. But hey, guess what? You don't have to solve that with just the graph database. There are better ways to solve some of these problems when we break them down. And then leverage the graph for the parts that it's good at.
Okay. That makes a lot of sense. Okay, so it sounds like in these customer interactions, you get a lot of exposure to the problems that people are trying to solve with graph processing, graph databases.
Yeah.
A lot of those requests for new capability roll into you. So what are you seeing? Like, what are the trends that you see coming up in terms of what people need in this space?
Yeah, it's a good question. So I would say, the graph market's still fairly young compared even to NoSQL or I hate using the term big data, but like the Hadoop markets.
Yeah, that's fine.
But so it's still early days, but there's definitely some, the graph database vendors where we're talking about, database vendors or processing engines, they've helped educate the market on some good canonical graph use cases, and we're seeing certainly trends in adoption there. So for instance, customer 360s.
Yes.
Fraud prevention.
Detection. Yep.
Another really interesting use case we're seeing a lot is permissions or authentication, more authorization.
Okay.
And what we're seeing is, particularly for larger companies or digital native offerings from companies. So like video game platforms, or if a company has multiple media channels, right? How do I control a single user's ability to access different pieces?
Okay.
Because it's a graph problem.
Would you call that an identity management problem, or is it bigger than that? It's about access control and.
It is larger than that, and I don't know the right term. I guess that's kind of my job. I need to think on that. But we lump it under the bucket of identity management internally. Yeah. But it's really it's a network problem at the heart of it.
That's right. And so I can think of it like groups. Interesting problem. Groups of users. I moved to a new department in my large IT organization.
Right.
What permissions should I keep? Which should go away? How many times have I been able to access things, gone back and been able to access things that I probably should have not been there anymore. And I was like, yeah, let's send an email to that person and make sure I get taken off that access list.
Well, then it gets more complicated when you flip it and you add in the security concerns that companies have today. So think not from the person level now. This is what I love about Graph, because you can just think from a single document perspective. Who has access to this document?
Yes. Okay.
What departments do they work in? Who do they know? Right?
Right.
Is there a chance that I have somebody that's going to leak something out that I don't want to? How do I control at that document level and track who has access to that?
Right. So, and that's the way that you're actually probably want to manage some of those sensitive documents and artifacts and systems, is from the perspective of the asset itself, not starting with the people.
Right. What's really nice about graph databases, so talking there, is the flexibility to attack a problem. I can attack it from the customer. I need to set up authorization for them to access the right things. But then I can go all the way down to this individual document and traverse my graph and figure out how those two things connect. And maybe I need to attack the problem now from the document level up.
Right.
Right. And very flexible way to do that, to model it and to access it.
Nice. Well, what other areas?
We are really getting into entity resolution a lot, and I mentioned that earlier.
Yeah, unpack that for those that are not familiar with that term.
Yeah, the real
in one sentence.
The mansplaining version of doing this is how can I tell that two people are different or they're actually the same? If I see two traces of a person, that may be a MAC address, maybe something from like a thumb reader, maybe a signature, anything like that. How can I tell that this signal, this piece of information, belongs to?
It's the same person, really.
Right, and that's very important for really all of these use cases. It's seminal, because without that piece, there's no way I can tell that this person has access to that document.
Right.
If there's no way to tell, I could overcount people, I could over-provision, all sorts of ramifications there. But that is something we are solving and this is why I love Denise on our team, because she has a PhD, this is her area of study. But we are solving really hard problems at scale around entity resolution. And it's fun, it's challenging, and as a product manager, somebody who's responsible for product line, I think it's going to be very rewarding for us as we look in the future.
Okay, so it's interesting to me how many of these use cases are strongly related to people and relationships, and it just makes it very fun in terms of the practicality of graph processing for solving these kinds of problems. So you're out there, you're hearing these needs and new areas in which graph is being applied, and what does that mean? What are the implications for our product, and where you're going with that?
Yeah, I mean, I can broad brush. I can't give you specifics. I'll list all the JIRAs too if you want me to. But no.
I guess I could write those down.
It's when you look at what we're doing, we have our mantra of being a fantastic cloud database that solves hard problems for companies that are looking to reap the rewards of clouds, protect themselves from being beholden to the cloud provider, because a lot of times what our customers are telling us that they are leveraging infrastructure from their competitor, right? Cloud competitors are
yes, we know who that might be, I think.
Right, and it's not just one company, really.
Right.
But yeah, so we have this great platform that's very flexible, hybrid cloud deployments, and providing graph capabilities on top of that. But when you look at what we're doing in this space, particularly, it gets around we'll use the term multi-model capabilities.
Yes.
Colloquially, using the right tool for the job, and without requiring you to retransform, restore, reprocess data. So where we're heading is...
Because that's where the mistakes happen.
Oh, man, yeah. See, this is near and dear to my heart as an enterprise architect kind of background with a focus on data. Yeah, correctness matters. And anytime you have you start forking rights, doing anything like that, you can get out of sync.
Exactly. Things break, things get dropped, messages get dropped. These things happen.
Right. Right, right. So the ability to write that data once and have this incredible platform distribute it and give you fine-grained controls how you want to distribute it globally across multiple data centers, but then access data through the right tool is where we're heading. So CQL, Gremlin, again, SQL, and really making that a great experience for our users so that they can build their applications quickly using the right tools for the job, taking advantage of all the thought we put into the platform, but also really being able to capitalize on the tools we have because their problems are getting harder. Connect, the relationships you spoke about, that is happening out in the world more and more as we put everything online about ourselves. We start like your Fitbit, your car, all that kind of stuff.
Oh boy.
Yeah, these are going to be real, they're real challenges and people need to solve them quickly and easily because they're being disrupted.
Right.
And that's the direction we're heading is enabling that environment. Here's a great place to store your data. It's going to be secure, globally distributed. You have controls over that.
Yeah.
And then you have the ability to, again, use the right tool for the job without requiring you to rewrite your data.
So that's really interesting. You're mentioning kind of all this data that's being reported about us, that we're self-reporting by using social media, and that is being reported about us because of applications and sensors that we encounter all the time.
Yeah.
So is that a problem that Graph is going to be able to help us with at all?
It is, and it
privacy,
yeah, at an individual level, we're starting to see that in Europe is kind of leading the way with GDPR.
Yeah, absolutely.
We'll leave that for another show. But yes, so having the ability, GDPR is very explicit. I need the ability to get access to all of the data associated with me.
Yes, I need everything you have on me. I want to see it all.
Guess what that is? Graph problem.
Yes,
it's a graph problem.
Okay.
And so, sweet. Yes, we absolutely are setting up the ability to really control that and provide and enable enable our customers control that and enable their
Can you delete all that, please?
Right, right. That's right. That's exactly right. So, so that's for our own control of our own security and privacy. I think we're going to see that a lot more because the other interesting part is I'm really seeing how much of our information is being collected by companies, by users. And what they're trying to do with it, which is not for nefarious purposes, but they are collecting it. So a lot of cars, Waze, all that kind of stuff, we really don't think about with IoT sensor-based information and having the capability to tie it all to an individual person.
Right.
Are you okay?
Anonymization is.
Hopefully I'm not freaking you out right now.
No, we know that these things are happening, and
right.
The question is, the degree to which I trust that my identity is actually being removed from some of these records, I'm not so sure that that's happening as much as I would want.
Right, but yes, so we are enabling both sides of that, I would say.
Yeah.
So.
Okay, good. So what about this is how we've been talking about how we see the need evolving over the next few years and some of the new areas that the Graph is going to push more and more into. What needs to happen with the technology? Where do you see graph databases, graph processing going in the next several years?
Yeah, the biggest thing is really the API itself.
Okay.
So there are two fundamental graph database types. There's something called an RDF, and there's a property, and we're a property graph model.
Graph, right.
RDF has a standard language called Sparkle, and inside the property there's kind of the leading standard language, which is Gremlin, used by all sorts of vendors. And then there's Neo4j's Cypher, which has a couple of vendors associated with it as well. I don't think any of working with customers across that whole gambit and going to conferences and speaking with users, again, across that whole gambit just to learn, there's still a barrier to entry with whatever language you want to use. If people could just somehow use SQL to write.
Well, okay, so
which is like because it breaks all the constructs there, right?
Yeah, that would be different. I mean, one of the examples that I like to share with people is the example of some of these traversals, just like in terms of navigating relationships between people or something like that. And you look by comparison at the SQL statements that you would have to write for that, and what a mess it is, and multiple levels of joins, et cetera. And then the simplicity, just in terms of the sheer length of the query, is much smaller with Gremlin. But if you start to dive into that, if you have a programming background, you can look and see this is a fluent API. I can sort of begin to follow this.
Pattern, sure.
But I mean, there is a learning curve because it isn't like something that you've used before.
Right.
So what do we do?
Right. So we're doing a couple of different things. There's just you're helping, by the way, so thank you.
Oh, okay.
Pure education, getting the message out, lots of tutorials, examples, providing a message in as many different ways to be consumable by users as possible.
Right.
So that's attacking the problem from an education perspective, an enablement perspective.
Right.
The DataStax Academy Slack room is awesome for that, right? I don't know if you talk about that, but we're on there. DataStax folks are always on this Slack channel.
Yes, you can find us there, and you can get feedback and response to questions there. Yes, hit us up on Slack.
Yeah.
Absolutely.
But then there's also things we're looking at from a language perspective. So we mentioned DataStax 6.0 with always-on Spark SQL. That literally does allow you for very simple things to write SQL against your full set of vertices and full set of edges. We don't want to recreate the environment where you have this terrible 50 join, nested correlated subquery type of, that's my fancy SQL word, by the way, scenario. Yeah, with complex. But we do need to solve this learning curve. So one of the things that we are starting to invest in is something we'll call domain-specific languages.
Yes, okay.
So the concept has been around for a while. In fact, I would say a lot of the BI tools, like the old school, here's an old BI tool reference for you. Ever heard of Brio?
I have not.
Yeah, so it's like old school.
Okay.
But business objects and Tableau and all of these tools, what they do is essentially provide a semantic layer on top of the data, and they abstract all the physical formats. So business users, analysts, give me a customer, give me their name, right? Drag and drop.
Yeah.
Gremlin provides that capability. That was released this past year some point, and we're, as DataStax, as a database provider, looking at how do we provide a standard set of these domain-specific languages for key use cases that we're seeing over and over. So instead of having to have
not just the ability for, like I know that we've had for a while, in Java, the ability to create your own domain-specific language, and that's coming more and more into C# and Node. Is that right?
I think it's Python. It's definitely C#.
Python. Sorry, remember
one of those two.
Remember which driver it is. My bad. But you're talking about actually contributing to different industries, creation of domain-specific languages that are kind of that we can start standardizing around.
Right, and then extending is certainly one area we're looking at. And again, it takes the verbosity, which is not as bad, definitely more brief than SQL. But for folks who are not technical, who don't understand the builder patterns and how to write Gremlin, just customer.name, bam.
Yes.
Or look up this customer. It's literally working with the objects in the native languages of our business users. So that's a big area we're going at. So when you look at, we have this swath of enablement and education, and then advantages in the product itself, either accessing graph data through more natural, for very simple traversals or queries or lookups, SQL. How do we extend and build on top of Gremlin's DSLs to enable our business users to have a nice tool, a nice way to interact with data as well.
Right, good. Ease of use is everything. Education and ease of use, right? Getting people to where they can be productive. Right. So do you have any final thoughts for us?
No, I think, yeah. So I think this is going to be, I'm very excited. Sorry, I get excited.
No, I knew you would.
Yeah, I got like 80.
Just one.
Oh, okay. Yeah, I'm really excited now that DSE 6.0 is out.
Yeah.
We have a lot of really practical but very cool and fundamentally changing technology that's going to come out here as we look forward. 6.0 is like the foundation. And what we're going to be able to do now, and I can't talk about specifics yet.
Yeah, okay.
Holy cow, it's going to change the graph space categorically, and I'm really excited for that. I'm really excited to take part of it, and I'm kind of honored and privileged to do that. And then also, we want to hear feedback.
Yes. Okay.
I'm on that public Slack channel. People can always reach me. It's at Lacefield. I'm a pretty heavy participant in our Stack Overflow as well. And Denise, same way. She also, my partner in crime, want to hear that feedback from users, customers. It'd be great to
Excellent.
have.
And that's anything from how does this work, or teach me how to do this, to I think this might be a bug, or this might be broken, or there's a rough edge here that I need to help me out with, and you do it all.
And then even what we really love is when people just talk about their problems. Is this a graph problem or not? All right, does this require a graph database or not? Because those are great conversations. They're very, very meaningful. It's good stuff. So yeah.
Excellent. Well, I appreciate all that you're doing in the graph space in particular, and appreciate having you on again. And we would like to call first dibs on when you have things that you can share about where graph is going in future releases. Come back. We will talk.
You don't
have to wait that long. You don't have to wait until the next release comes out, but it's fine. Whenever, we'd love to have you on. Thank you very much.
Yeah, thanks. Have your people call my people. It'll be great.
That'll be good.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel, or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.